Hello, so for this video we are going to redefine a bunch of modulus functions. So let's start with a single one, a very basic single one that says f of x is equal to negative 2, the modulus of 5x minus 4. Yeah, so this is the one that we are redefining. So redefining this one and then sketching it. So first of all, we need to find our breakpoint. So to find our breakpoint, we just need to get what is in the modular symbols and then equate it to 0 and solve for x. So we're going to say 5x minus 4 is equal to 0. So from this, we can say 4 is equal, or x is equal to 4 over 5, which is somehow equivalent to like a 0.8. Yeah. So we have this. So this is our breakpoint. So if you were to reflect this on the number line, you'd have something that says, so this is 4 over 5. So you'd have two regions, I can say. So region A, where x is less than 4 over 5, and then region B, where x is greater than 4 over 5. So these are the two regions that this breakpoint is going to separate your number line. Yeah. So we're going to work with these two regions to redefine our function. We're going to say, alright, our redefined function is going to be defined by these two regions. So we're going to have the same modulus function that we had. So this is for the part that says x is less than 4 over 5. And then this other part we can say negative 2 modulus of 5x minus 4 modulus. So this is where x is greater than 4 over 5. So what we do here is we're going to introduce an equal sign to one of the two expressions. So we can introduce to any of them. It's up to you, free will. So I want to introduce it here because I don't want to change color. So here, green goes. So I'm going to introduce my equal sign there. So even if you introduce your equal sign here, it's still right. It's still right. So just introduce it at one place, not at both places. Just one place is enough. So what next you're going to do here is that you're going to test for your intervals. Yeah. So you test your intervals. So what I'm saying is this. So here we have x is less than 4 over 5. So the simplest number I can pick that is less than 4 over 5 is 0. So if I let me get my 0 and then replace it in the first expression, since this first expression is defined by this interval. So if I replace 0 here, it's going to give me negative 4 inside the modular symbols. So I'm interested in the sign that it's giving me inside. So this is negative 4. So it's giving me a negative number. So if it does that, if it gives me a negative number inside my modular symbols, then I have to multiply the whole expression by negative. Yeah. So it's going to be like this. Since it's already negative outside, it's just going to be positive 2, and then my modulus brackets change to curly bracket 5x minus 4, like that. So not forgetting the interval, this is 4 over 5. And then my other interval, if I were to replace something greater than 4 over 5, so let's say I replace 1 in this first expression, it's going to give me positive inside the modulus here. It's going to give me a positive. So if it gives me a positive, I don't do anything, I just write it the way it is. So it's going to be negative 2, and then curly brackets 5x minus 4, like that. And then x is greater or equal to 4 over 5. Cool. So next thing that I'm going to do is that I'm going to evaluate out both of my expressions. So for the top, I'm going to have what? I'm going to have a 10x minus 8 for the top, and then for the bottom, I'm going to have a minus 10x and then plus 8 for the bottom. So these are my two equations that I'm getting from my modulus function. So I can write them as follows, where I can have my f of x is equal to the first one was what? 10x minus 8, and then the interval here was where x is less than 4 over 5, and then the other one is what? Negative 10x plus 8. So this is where x is greater or equal to 4 over 5. Yeah. So redefining, I'm done. So the only thing that's left is to sketch these two lines. So to sketch them, I kind of need a few extra points. So for the first graph here, where y is equal to 10x minus 8, so I'm going to come up with my boxy box like that, and then I'm going to pick two numbers that agree with my interval. So this is less than 4 over 5, so I'm going to put my 4 over 5 there. Then I'm going to pick something that's less than 4 over 5. So I'm going to pick a what? I can pick a 0, yeah? 0. So if I place 0 here, it's going to give me negative 8. If I replace 4 over 5 in this expression, it's going to give me a 0. So this is my first part. And then my second part is negative 10x plus 8. So again, I am going to get two numbers respecting my interval. So x there, y there, so 4 over 5 there, and then I'm going to pick something greater than 4 over 5. So I can pick directly a 1. So here it's going to give me a 0, and then here it's going to give me a what? Negative 2. So all I need to do is plot these 2 points. So here's how it's going to come out. So if I have this and this, so let me indicate my breakpoints using dotted lines. So this is my 1, my 4 over 5 should be somewhere here, so my dotted line should pass somewhere there. And then I plot my coordinates that I had. So the first one that I had for y is equal to 10x minus 8 was 0, negative 8 and 4 over 5, 0. So 0, negative 8, I can assume it's somewhere there. And then 0, 4 over 5 is somewhere there. And then for the other one I had 4 over 5, 0, and then 1, negative 2. So which is that point there, and I can estimate it to be somewhere there. So my final graph is going to come out like this. So it's going to come out like ba ba ba. So this is going to be my f of x is equal to negative 2 modulus of 5x minus 4. So that is how you redefine and then sketch your modulus function. So that is if you have a single function. However, under the same question, if they just told you to say sketch, they haven't told you to redefine, they just told you to say sketch the function f of x is equal to negative 2 and then 5x minus 4. So answering this one according to standard procedures, you just have one graph like that, and then you would start with your original format like that. So this is going to be modulus of x, and then from there you're going to get what's in your bracket, equate to 0 and solve. So this is going to be 4 over 5, so your graph will shift to 4 over 5 there. So it's going to come like this, yeah. So this is 5x minus 4 like that, and then after that you're going to have a 2. Now you're supposed to know how this 2 affects your overall graph. How does this 2 affect your overall graph? Yeah, so we have a thing that we call shrinking and swelling. So this 2 is going to make your graph shrink, right? So meaning that you're going to have something inner, inside, hitting there, hitting there, hitting there. So this one here is going to be a 2 modulus of 5x minus 4. Oh, sorry, modulus. And then the last one is the negative part. So just this green one will just bend downwards into this blue one here. So it's going to be like this and like this. And it's going to be negative 2 modulus of 5x minus 4. So this is how you graph it if they just told you to say sketch without redefining sketch. So this is what you do. But if they told you to say redefine, then you do the previous thing that we did. Yeah. So all in all, your final graph must look the same. And then let's try and redefine something more complex. This time, let's try to redefine something big. So let's say we have f of x is equal to 3x plus 1 plus 2x minus 3 like that. And then step number 1, breakpoints. So here we're going to have 2 breakpoints. Previously we had 1, but this time we're going to have 2 breakpoints. So our breakpoints are going to be 3x plus 1 equal to 0. So x will be equal to negative 1 over 3. And then your other breakpoint is going to be 2x minus 3 is equal to 0. So x will be equal to 3 over 2. So reflecting this on your number line, you'd have something like negative 1 over 3 here, and then you have 3 over 2 here. So you're going to have 3 regions this time, so region A, region B, and region C. So how would you define region A? Region A is simply values of x that are less than negative 1 over 3. Region B is where negative 1 over 3 is less than x, but x is less than 3 over 2. And then region C is where x is greater than 3 over 2. So meaning for each of these intervals, you must have a graph to define the behavior of your piecewise, of your commodulus function. So we're going to do this. We're going to write it in this format. We're going to say f of x is equal to, break it down like that. So we're going to write our modulus functions in all of the three intervals. So we're going to have 3x plus 1 modulus, and then plus 2x minus 3. So this first interval is where x is less than negative 1 over 3. Okay, and then the next part is 3x plus 1. Keep my modulus sign, 2x minus 3. So the second interval was where negative 1 over 3 is this, that, this, that. And then my last interval should be 3x plus 1 plus 1, 2x minus 3. So this is where x is greater than 3 over 2. And then here I need to introduce equal signs to two parts. So previously I added my equal sign to one part, but here I'm going to add it to two parts. I need to add it to two parts since we have two breakpoints, so I need to add it on two parts. So I need to add it on two parts, but the only rule is that I can't add it on the same number. Like I can't add my equal sign here and here. It won't make sense because this is negative 1 over 3, this is negative 1 over 3. So if I add it there, I must add it here, or I must add it there. Okay, so or I can say I can add it there and there, or if I want I can add it there and there. It really doesn't matter. All that matters is that it's at two places and it's not at the same number. So I can say it's going to be there and there like that. Yeah, and then I can move. So at this point here I need to test my interval into my modulus functions. If it gives me negative, I multiply the expression by negative. So here it's going to be like let me pick a number that is less than negative 1 over 3. So I can say negative 1 is the easiest. So replacing negative 1 in the first expression here, it's going to give me a negative inside my modulus. It's going to give me a negative 2. So I'm interested in the sign which is negative. So if it gives me negative, what do? I multiply the whole expression by negative. So I'm going to say here f of x is equal to what? So this f of x is equal to negative 3x plus 1. Cool. The next part here, I replace the same negative 1 inside the second modulus expression. It's going to give me a negative 5. So negative, so I'm going to multiply it by negative. So it's going to be negative 2x minus 3. Yeah, so here it was positive, and then when I multiplied the expression by negative, it became negative 2x minus 3. Cool. I continue on. So I'm done with the first part, so I go to my next part here. So moving on to my next part here, following my interval, something in between negative 1 over 3 and 3 over 2, so that's going to be a 0. So if I place 0 in this first expression here, it's going to give me a positive 1, and since it's positive, I won't do anything to it. I'll just write it the way it is, but under curly brackets. Yeah. And then the second part here, if I replace 0 here, it's going to give me negative 3. So since it's negative, I need to multiply it by what? Negative outside. 2x minus 3 there. And then what is my interval? My interval is negative 1 over 3. This, that, 3 over 2. I forgot my first interval where x was less than or equal to 1 over 3. And then my last part, which is this part here. Again, I test for my interval. So this is 3 over 2, which is like a 1.5. So something greater than that is like a 2. So replacing 2 here is going to give me a positive something. So I just write it the way it is. 3x plus 1. It's also going to give me a positive number. So that's going to be 2x minus 3. So the interval here is this. So next thing here is just to evaluate what you have. So distribute the negative sign in here and then add it with what you have there. Okay, add it with what you have there. So the answers should give you something in the ranges of so for the first part we should have a negative 5x plus 2. That's for the first part. And then the second part should be x plus 4, and then the last part should be 5x minus 2. So notice that the first expression and the last expression should always be the opposite of each other in terms of the sign, negative, positive, and stuff like that. So not forgetting your intervals. So this is where x was less than negative 1 over 3, where negative 1 over 3 was less than x, but x was less than 3 over 2, and then here x is greater than 3 over 2. So here you need to create points for your sketch. Yeah, so you need to create your points, but even your breakpoints must be included in those points that you're going to make. So for example, for the first number, or for the first function which says y is equal to negative 5x plus 2, so my box of values x and y is going to be such that it's going to have two numbers. It's going to have the breakpoint, which is negative 1 over 3, and then plus an additional number that is less than x, because that is what this interval is saying. So I can say negative 1. So negative 1 here will give me negative 7, and then negative 1 over 3 will give me 11 over 3. Yeah, so that is my first table of values. So my next part is y is equal to x plus 4. So this one touches both breakpoints, so it's going to be in my box plus one additional point. Yeah, so that I'm going to have 3 boxes in here. So my two breakpoints are negative 1 over 3 and 3 over 2. Something in between these breakpoints is 0. So I'm going to have 11 over 3 here. If I get this and replace it in this expression, it should give me 11 over 3. If I put a 0, it's going to give me what? A 4. If I replace a 3 over 2, it's going to give me an 11 over 2. So that's my second part. And then my last part is where y is equal to 5x minus 2, where we're going to have an x there, a y there. So here we can just have two coordinates because we only have one breakpoint plus one additional sign. So here we can say the breakpoint that is touching this is 3 over 2 plus an additional point greater than 3 over 2 is simply a 2. So this is going to be 8 down there, and then this is going to be an 11 over 2. So having all these points, these are enough for you to graph your graph very graphically. So we're going to say this. So we're going to have our x, y plane like that. And then we're going to start by indicating our breakpoints on our graph. So our breakpoints were negative 1 over 3 and 3 over 2. So we're going to pretend negative 1 over 3 is there. And we're also going to pretend 3 over 2 is there. So we also need to identify our decimal points. So the first one that we had said what? The first point that we had from the line that says y is equal to negative 5x plus 2, we had a negative 1 comma negative 7. So negative 1 should be somewhere here, and then negative 7 should be on the top there. So that's going to be somewhere there. And then negative 1 over 3 comma negative 11 over 3. So it should be somewhere there. So this one is the part where it touches the breakpoint, so it should be somewhere there. So we're just estimating. And the next point, which is negative 1 over 3 comma 11 over 3. Now this one from the second function, from the middle function, yeah, since they all have the same points. So this other one, which is in blue, is also going to start from there, and then it's going to pass at 0,4, which is somewhere there, and it's also going to pass at 3 over 2 comma 11 over 2, which is somewhere there. And the last one is saying 3 over 2 comma 11 over 2, which is at the same point there, and then comma 2 8, which should be somewhere way beyond somewhere there. So your final graph should come out like it starts from there, it touches there, and then it goes all the way up there. So there should be a corner here that I'm missing, but all in all, your final graph should look something like this. So this is how you define a modulus function. So go try some crazy functions out there.